Welcome back. This time we're going to go over training in our RNNs with TensorFlow and hyperparameter tuning in SageMaker. Before we get started, hit the like button, subscribe, and share with anyone you know taking the AWS Machine Learning Specialty or Machine Learning Associate exam. Excuse me. All right, so how do you build a custom RNN in SageMaker? So SageMaker Studio Notebooks provide a complete environment for creating and training RNN models with LSTM or GRU cells. This workflow starts with setting up your development environment and progressing through model definitions, data prep, and training. We're not going to go into this in detail, but know that you need to go to the console. You need to go to SageMaker Studio. Ooh, okay. All right, see this feature? All right. Okay. Right here. All right. And then you can set up your first studio domain, install your TensorFlow, prepare your data in S3, and train your model. It's going to be a lot more timely, so we're not going to do that now, but this is a broad overview. Once you start training, you're going to monitor your training process through the output logs and CloudWatch metrics that you've set up. The training is going to consume a lot of computational resources, much more than simpler architectures, because it's going to use GPU instances. All right. So this can cost anywhere from $1 to $3 to $5 an hour for training. You could use inference on some CPUs instances, which will cost a lot less, but it'll take a lot more time. So then you'll also have to worry about your studio notebook, your EBS storage, and your storage for your S3. That's your AWS integration as well. Remember, you can reduce expenses by using spot training jobs in SageMaker, which can cut costs around 50 to 90% when you're using your S3, you're storing it in your checkpoint, and you can reuse this information rather than retraining from scratch. All right. Within this, and these are more getting towards production, you have your hyperparameters, which we've gone over. Hyperparameters selects the optimal combination of tuning. All right. So that means it configures your values to improve training convergence and model accuracy. The critical skill determines whether your model succeeds or fails, right? So regardless of the architecture quality, this is the most important. Why? Because a poorly chosen hyperparameter, like an overly aggressive learning rate or an oversized batch size, can prevent convergence and cause overfitting or trap training in local minima. All right, so a couple things. Learning rate can control how large the step optimizer takes when updating model weights during gradient descent. If it's too high and training overshoots the optimal solution, this can cause instability or divergence. If it's too low and convergence becomes painfully slow, this wastes time and risks suboptimal local minima. So think of minimizing a loss function as descending a hill. Large steps might skip over the valley entirely. Small steps inch towards the bottom, but take a lot of time. The optimal learning rate balances speed with stability. Then you have to worry about batch size. Right? So batch size determines how many training samples process before updating weights. Each epoch splits the data sets into these batches. Small batch sizes introduce stochastic noise that helps escape local minima, though training progresses slower. This noise often improves generalization to unseen data. Large batch sizes produce more stable gradients, but easily get stuck in local minima. So they may also show inconsistent results across training runs due to data shuffling effects. For better generalization, use smaller batch sizes in the 16 to 32 range. Remember, also, SageMaker has a hyperparameter optimization. So SageMaker Studio provides built-in hot hyperparameter optimizations that uses Bayesian optimization to intelligently search the parameter space. It works with both built-in algorithms and custom training scripts, tuning learning rate, batch size, layer counts, optimizer choice, regularization parameters, and this optimization saves time compared to manual grid or random search while using compute resources much more efficiently. All right. So we talked about the costs. You want to make sure your GPU instances are going to be monitored. You can use those in conjunction with spot instances, and then you can reduce that, but monitor that usage through CloudWatch logs or the SageMaker outputs. Then you can look at your S3 and EBS storage for those incremental costs, And then you also want to make sure that your endpoints are not permanent, so you can run this in batches. Um, Alternatively, beyond SageMaker native, there's there's other frameworks that integrate with the studio, right? You can use Keras Tuner, that's Keras Tuner, which works with Studio Notebooks for TensorFlow models. RayTune also provides distributed tuning across multiple instances. Optuna can offer a lightweight, flexible optimization framework, and all of them run within SageMaker Studio or training jobs using custom containers, giving you some flexibility and tuning approach. So for certifications, remember these essentials. When an exam asks about optimizing model training, avoiding local minima, or automating hyperparameter search, SageMaker's hyperparameter tuning with appropriate learning rates and batch sizes is your answer. So thank you for joining. But we're going to get out of here. Before we do, hit the like button, subscribe, and share this with anyone you know taking the AWS Machine Learning Associate exam. Thank you, and have a good day.